Assalamu alaikum to you all. I would like to welcome you to our first lab for the data structure course. The objective of the lab sessions, as I'm sure you are all aware, is to give you a chance to practice what has been taught in the lecture sessions. This is very important, especially for a programming course like data structures. Now in each lab, I will explain the examples for that lab. Mostly they are the same as the examples we already discussed in the class, but they are put together as complete programs so that you can actually run and see how they work. Okay. Now, based on the examples, a set of programming tasks are then given to you, and you are expected to solve these programming tasks within the lab time and submit them through Blackboard. Of course, I'm available throughout the lab period to help and guide you in case you get stuck in some of the tasks. For example, if you encounter an unusual error that you cannot figure out how to resolve it, you can contact me immediately and I will try to help you. I must emphasize at this point that you are actually expected to solve the lab tasks on your own, not as a group of friends, and certainly not by getting the code from the internet or somewhere else. That will defeat the purpose of the learning process. It can also lead you to getting a 0 grade for that particular lab. So please be responsible. Do the task on your own and do not engage in plagiarism. Okay. Now, this being the first lab, there are a few important points that I need to explain before we get started. Number one is that we shall be using NetBeans as the IDE for writing and testing the programs. I'm sure all of you are familiar with NetBeans. So if you do not already have NetBeans on your computer, please download and install it on your machine. Of course, as you are all aware, before you can install NetBeans, you have to install the JDK first. Okay, this is one. The second point is that the examples for each lab, they are combined together as one NetBeans project, which is normally named according to the lab number. So for example, for this lab, the project is named Lab 01. Okay, so that is how they are named: Lab 01, Lab 02, and so on for each lab. This NetBeans project, along with the lab document, like the one I'm going to go through now, are zipped together in one zip file. And the zip file again is named according to the lab number. Okay, and you are expected to download this zip file from Blackboard. Let me show you actually how you can download the zip file, and then we can continue from there. So you go to Blackboard and try to go to this content area called Slides and Lab Documents. This is where I am already. And you see that on the left side of this page, there are lecture slides, and on the right side, there are lab documents. So this is where the zip file are. For example, to download the zip file for this first lab, just click this single linked list, and it will download a zip file for you. I will not download it because I have already done so. Yeah, so you need to download the zip file for the particular lab. Now, you need to, first of all, unzip the zip file. So if I can just go up in this my folder, When you download the zip file, it may be somewhere under your download, so you may need to copy it to somewhere else. What I suggest is you should have a specific folder for the labs in this course. You can call that folder, for example, CS205 or CS241, depending on which version of the course you are taking, or any particular name that you want, so that you know all your lab files, they are in a specific folder. Okay, so I suggest you first of all copy the zip file from your download folder into that folder, like I have just done now. You can see the zip file is here. Okay, then the next step is to unzip this file. Depending on the unzipping program you have on your system, I am using 7-zip, so if I right click on this file, you will see 7-zip will show up in the menu, and I will just say extract files or extract here. Okay, so the zip file has to be unzipped first before you can begin. It will store the files inside the zip file in a folder with the same name. So for example, after unzipping lab 01, this is what I have. Okay, I have two files, a document with the same name, lab01.doc. This is actually the document I'm already viewing here. So you can double click this document to open it. But this subfolder here is actually a NetBeans project. So do not try to open it directly. Rather, you need to first of all open NetBeans. Okay. Let me. Well, I will not close the project because I have already opened it, but I will still show you how to open. You just say File, Open Project. So this will open a browsing window which you can use to browse to locate the location of the file. Okay, so for example, if they are in a folder, you go to that folder, and then the folder for the particular lab 01, this is the project. So just say open project to open it. Okay, I have already opened mine, so I don't have to open it again, but just to show you the process. So this is the idea. The first step, download the zip file. Second step, unzip it. Okay, after unzipping it, you have two items. One of them is a Word document, just open it directly. But the subfolder that you're gonna see as the second item is open from NetBeans. So you have to start NetBeans and then open the project. Okay, so these are basically the steps. Now I think we can start looking at the lab document to see what we have for this first lab. Right, so the lab, as the title suggests, is about singly linked lists. This is what we have learned so far in the course. And the objective is always twofold. One, to learn how to implement singly linked lists. And the second one is to learn how to use singly linked list. Okay, this is the objective of both the lecture and the lab actually. And this is normally followed by the examples. As I mentioned just now, the examples are not different from the ones we have already discussed in the class. Rather, they are put together because in the lecture slide we just have them as pieces of methods, discuss the individual methods, but now we have them as complete class with a test program that you can actually run to see how the methods fit together. So here in the example it says you are given a class called SLL, which implements a generic singly linked list, okay, that can store any type of data. Because it is generic, you can store any data in it. and it has within it another class, so an inner class inside SSL, which is the SLL node. These are the two classes we have seen from the lecture, with all the methods already discussed. So before we proceed, let me just show you this class, or these two classes. This is the SSL class. I have already opened it, and as you can see, it is exactly as we discussed. Maybe before I discuss the class itself, that is the outer class, let's go down and see the inner class, which is the SLL node. Okay, so this is the SLL node to represent the node of a singly linked list. It is exactly as we discussed in the class. It has two variables, info and next, and three constructors that can be used to initialize an object of the node. Okay, again, nothing to discuss. We have already discussed the different constructors. So notice this class is within the SLL class. Why? Because a node of a linked list can only exist in the context of linked list. So it doesn't make sense to have it actually as a separate class outside. Normally it should be put as an inner class from the design principle. Okay, it's just like having a department, for example, CS department cannot exist without the college. So we should have the department within the college. The same idea in terms of object-oriented design. If you have a class that can only exist in the context of another class, then by design it should be an inner class within the outer class. Okay, so let's go back to the SLL class itself. Again, there is nothing really to explain. It's just that all the methods that we already discussed, they are now put together in one class. So we have the instance variables, head and tail. The constructor is empty. Then the two add methods, add to head and add to tail. The two delete methods, delete from head, delete from tail. The general delete method, that you can delete a node just by receiving the info of that node. And finally, the print all and find. There is none of this method that we have not already explained. If you are not clear with any of this, please refer back to the lecture slides and also the video, because I have recorded again all the explanation in a video, so you can go through the video to remind yourself about the explanation. So this is a singly linked list class. Now the document is telling us, apart from this, we are also given another class called test integer SLL. This class is the one probably I need to explain. It shows how to use the singly linked list class to perform the operations of the class. So we have options in that class. So this is actually a main class. It has a main method, so you can actually run it. And we're going to see that it has options to allow you to call all the methods that are implemented in the class. So you can test the add to head method, add a node to the tail, print all the elements, delete from head, delete from tail, delete a given node, and search for a node. So basically, there's an option to test each of the methods already discussed in the singly linked list class. Let us go and see that class. So this is the test integer SLL. Okay, it's going to be reading input from the user, so that's why we are importing the scanner class here. Okay, but it has just the main method. As I told you, it is a main class, so it has a main method. And the first thing we do is we create an object of our SLL. because this class is designed just for the purpose of testing the singly linked list class. So to test the singly linked list class, you need to first create an object of the class. Okay, so we have here SLL of integer. It is at this point that we define what is our T. Remember, the singly linked list is generic with a type T. So when you are testing it, you have to actually give the actual type. Here we are testing it with integer type. So SLL of integer list equal to new SLL of integer. So this is our list. Currently it is empty, but we're going to allow the user options to add and delete and do all the things that we have implemented in that class. Okay, right. We have a few variables here which we're going to need. Option to allow the user to select which of these options he will want to test. And then target. This we're going to use later. For example, when we are searching, we have to receive a target from the user to search. Or if you want to test the general delete method, remember you have to give the info that you wish to delete. So we're going to receive that as target. Okay, and then of course we have a scanner object which we call reader. We're going to use this to read input from the user. Type. So after these variables, we have a do while loop. Okay, so this actually runs until the end of the class. This is the end of the do while loop. The idea is we're going to be displaying a menu of options and then ask the user to enter his option, and based on the option he has chosen, we will do one of the cases. Okay, now this is appropriate place to use a do while loop. If you have to do something, definitely if you are sure your loop will execute at least once, then it is a good place to use while loop. Do while loop. If you are not sure that your loop will execute at least once, then in that case the guideline is to use a while loop. If it will execute 0 or more times, you go for while loop. If it will execute 1 or more times, you use do while loop. So here we are sure our loop will execute at least one time because we're going to display the menu for the user. This definitely we will do. So the loop has to execute at least one time. So it's better to use do while. Good. Now this is the menu. It's just a bunch of print statements displaying the options for the user. Okay. So option 1, add to head. Option 2, add to tail, and so on and so forth. So this will display a menu for the user, and then read his options. So this statement here is saying select an option from 1 to 8. Option 8 being the one to quit. So now we're gonna read his option, which is gonna be an integer. So we're gonna say reader.nextInt, and whatever he types, we're gonna save it in our variable option, which I explained earlier. This is the option. So now based on his option, we're going to run through the switch statement here. If the option matches 1, then it means he wishes to add a node at the beginning of the list. So we're going to ask him enter the element to add at the head, and then we will read the value he enters. Now, after reading the value, how do we add it to the beginning of the list? Obviously by calling the add to head method. Okay, but this method is a method of our linked list, so you have to say list.add to head. Okay, so we say here list.add to head the value entered by the user. If you wish, you can save this variable this value in a variable first. before you call add to head, but there is no need to do that. You can just put the reader.nextInt as the argument for the add to head directly. Okay. Yeah, and the other option is to say, for example, int input equal to reader.nextInt. So read the input first. Then you can now say list.add to head the input. This is another way of doing it, but there is really no need. You can call this method directly and pass it to the add to head method as your argument. Okay, this is the idea. So this is option 1. In case he enters option 2, then it means he wishes to add to tell. So again, we have to read the input from the user. So give him always a prompt so that he knows what to do. And then you read the value and then call add to tell with that value. Okay. Option 3, he would like to print all the elements. This doesn't need any input from the user. So you just say list.print_all. Yani, as you can see, the add to head and the add to tell, they receive input or they expect some input. But print all doesn't need any input. So you don't need to read anything from the user. Just call the method by saying list.print_all. Okay. The same thing, the delete method, they don't need any input. So to delete from head, just say list.delete from head. List.delete from tell. All right. But option 6 and 7, they need an input. Option 6 is to delete a given node. So this is the generic delete method where we have to read the input from the user to receive the info value, and then we will search for a node that has that info value and delete it. Okay, so this is how it goes. It says enter the node to delete, and we read the value, save it as target. I explained the target variable earlier, and now we call delete the delete method. So we say list.delete. Now here you have to be careful. Most of the other methods that we have seen before, they are all void. If you check, print all, for example, is void. The add method, they are all void. Add to tell, add to head. But the delete method here is not void. Okay, it returns a value. And actually, even delete from tell and delete from head, they are not void, but we didn't need to receive the result. Okay, because here we need to be careful. The element may not exist, so we need to tell the user what happens, whether the deletion was successful or not. Okay, so the first thing we do is to save the result returned by the delete in a variable called result. So this is the result of the deletion. It could be null if the target was not found, or it could be the value that has been deleted. Okay. Now the reason why we are saving this in a variable so that we can print a nice message to the user so that he knows whether the element actually was deleted or not. Okay, so we have an if statement here saying if result is not null, then we tell the user the element result has been deleted. But if it is null, we should tell the user, sorry, the element target is not in the list. Okay, this is the idea of saving the result. Okay, we didn't need to do this in the case of delete from head and delete from tail, so no need to save the variable in that case. And no need to save the results in that case. Okay. The last option is the search method. So this is very similar to the general delete. We need to receive an input because we are trying to search for a given value. So we need to ask the user enter the node to search for. Read that value that he wished to search, save it in target. Okay, so again we need to know what is the result of find. Is it null or not? You can do it directly as I'm doing it here, or you can save your result in a variable just like we did here with the delete. Okay, so you can say integer result equal to list.find target, and then you can say if result is not null. Okay, but another way of doing it is as I'm doing here, just check the result returned by the method. If list.find target is not null, then again we tell the user the target is in the list, otherwise sorry, the target is not found. Okay, so this is the test class. Let us try to run it and see how it works. Now this is another important point I should mention to you, Shabab, because maybe this is the first time you are encountering this. Normally when you have a NetBeans project, usually there is only one main class. So to run the project, you just click the run button here. But as we shall see in this course, usually we have more than one main class. I'm going to show you another example, which is called test item SLL. This is also another main class. So if you have more than one main class in your project, it doesn't make sense to just say run, because NetBeans is going to get confused. It doesn't know which of the main class to run. Rather, the way to do it actually is to right click on the particular main class that you wish to run. Okay, just right click, and among the options that you're going to see in the menu is run file. So this is the way to run the particular application you want to run. So just say run file. In that case, that means it's very clear which of the two main classes to run. Okay, so run test integer SLL will actually run the program. It is still trying to run, so let's give it a few seconds. Okay, right now it is here. So as you can see, a menu has been displayed with the options as expected. So let us try to test each of these options. For example, if you choose option 1, it will ask you enter the element to add to head. Let's say we want to add 2. Okay, so again it will come back and display the menu again. So the assumption here is the element has already been added, but how do we know it has been added? The best way to do that is to print the elements in the list at the moment. So option 3 will show you that right now there is 2 in the list. Okay, good. Let's add one more. So option 1 again. This time let us say we want 5 to be added at the beginning of the list. So we expect our list to be 5, 2. Yeah. Okay, so we add, but again we have to go to option 3 to display the result. So this is the result, 5, 2. So you can see it seems our add to head is working correctly. Let us now try add to tail. So option 2, let's say we want to add 4, and then option 3 to display the result. You can see 4 has been added at the tail. So 5, 2, 4. All right. One more element to add, option 2. At the tail, let's say 10. Okay. So if you display the list again, option 3, you can see that 10 has been added at the end of the list. So definitely it looks like our add to head and add to tail, and of course print all, because it seems we almost always have to use print all to see the result. These 3 methods, definitely they are working correctly. Let us now try to, before we delete anything, let us try the search, okay, to see whether the searching method will work. Suppose you are searching for 4. So search is option 7. Okay, so it says enter the element to search. We want to search for 4. So it says the element 4 is in the list. Okay, this doesn't really look like it is helpful, as I explained in the class. To search for an element, you have to have the element first. If you have the element already, why are you searching for it? So the usefulness of this method really will come in the next example we're going to see, where the user has to give just the key, not the complete data. So that is where the usefulness of the find method will come. But for integers, it doesn't really make much sense. Okay, so we'll come back to this find in the second example here. Type. Now let's search for a value that doesn't exist. Let's say we want to search for 15. So option 7 again, we want to search for 15. And see the message we get here, sorry, element 15 is not in the list. Okay, so this is what we expect from the find. If it finds, it will tell you. Otherwise, it will give you a nice message. Type. Let us now try the deletion method. Let us start with this one. Remind ourselves the elements we have. We have 5, 2, 4, and 10. Now suppose we say we want to delete 4. 4 is in the middle. We want to delete it. So just go for option 6. Okay, enter the note to delete. We want to delete 4. So it says element 4 has been deleted. To verify that, print the elements again, option 3, and you see that the 4 has gone. Only 5, 2, and 10 are left. Okay. Delete from head will delete 5. Obviously, it doesn't need any input from us. So option 4 will delete from head. Let's do that. Option 4. Okay. So it didn't give you any message, but if you print, you see that 5 is gone. Okay. And finally, delete from tail should delete the 10, because 10 is the last element here. So if you go to option 5, you will see that 5 has been deleted. Just print the elements again, you will see that we have only 2. Okay, so this is the idea. All the methods that we have spent time discussing in the lecture, they are actually all working correctly. Great. Let's go back to our document. As our last example, it says we are also giving a class called test item SLL that shows how SLL can be used to manage a list of items object. Okay, so the idea of this example is to show you that the singly linked list class is really generic. It can take any type of data. So we're going to look at, first of all, the item class. What does it represent? And then we will run the test class to see whether it will help us manage objects of type items. Okay, so going back to NetBeans, this is the item class. It's a very small class which is designed to represent an item let's say in a shop. Okay, so we have a class item. Item has two instance variables, name and price. So each item has a name and it has a price. Name is of type string, and of course price is of type double. Okay, there are two constructors for the class. The main constructor will receive both input, both the name as n and the price as p, and those will be used to initialize our two instance variables. Okay, all right. The other constructor is very useful, as we shall see later when we come to testing the find method or even the delete method. The constructor receives only the name, okay, and it will create an item object with the name but with 0.0 as the price. Okay, good. Now, apart from these constructors, we have two important methods which you actually should always have when you write your class: equals and toStrings. Okay, these actually are inherited methods from the object class, but we want to override them. Okay, the equals method is designed to help us to know when to say two items are equal. Okay, so let us see how it is. Of course, since we are inheriting this method from the object class, we are overriding it. If you are overriding a method, you don't change the signature. The signature has to be like this. And this, so here the parameter is always object, even though we know the parameter we're going to receive is going to be of type item. We cannot say item here, otherwise we are defining a completely new method, and the Java system may not treat our method like the normal equal method. So this signature has to be like this. However, before we can do the comparison, because the idea is we're going to receive another item and we're going to compare it against the current item and decide whether they are equal or not. So the first thing is you have to decide what is the criteria for two items to be the same. Okay, given that we have only two variables, name and price, it doesn't make sense to say two items are the same if they have the same price. So obviously we're not gonna use the price, rather we're gonna use name. So two item objects are equal if they have the same name. Okay, now before you can do the comparison, however, you have to typecast this object that you receive to be of type item, because remember we can only compare items that are of the same type. You can compare orange and orange, or mango and mango, but not orange and mango. Okay, so what we have as the current object is type item, but what we receive is of type object. So the first step is to typecast this object to be type item, and this is I'm sure you know how to do this from Java 1 or Java 2. Right now they are called programming 1 and programming 2. To typecast a type like O to item, this is all you have to do, but you need to save it in a variable of type item. Okay, so this other object that we receive, we are typecasting it to be of type item. Okay, so now the question is, this one and this current one, are they having the same name? If yes, then we're going to conclude that they are the same. Okay, luckily the name, which is type string, has equals method. Remember, string has equals, so that's what we're going to use. We're going to say return true that the two objects are equal if the name of the current object is equal to the name of the other object. Okay, this is the other item object. So other.name, if it is equal to this.name, if you like, you can call it this.name. Okay, but no need, since we are calling this its object. So return true if name.equals other.name. Okay, so this is the equals method. This is the one that will be used by the program to check if two items are equal. So for example, when we are doing find, the find is going to be based on name only, not based on the price. So when you are sending your argument, you only need to send the name. Don't bother sending the price, because it's not going to be used for the comparison anyway. It's only going to compare based on name. Okay. The last method is the toString method. So toString is expected to give us the information in our two variables as a string. So you can see it simply returns the name and price separated by tab. Shabab, this is very important. I'm going to ask you as one of the tasks to write another class similar to this called student. And one of the tasks that you will do is to write a toString for the student class. Now, many students in the past, they allow NetBeans to generate a toString for their class. This is not acceptable for me in this course. Why? Because the toString generated by NetBeans is having information that is not necessary. For example, it will include the name of the variable and then the value of the variable. I don't need the name of the variable, only the value. So please do it by hand, by yourself. Just the variables in the class separated by tab. That's what we want in a toString, okay? Don't use the toString generated by NetBeans. Also, don't use the equals generated by NetBeans, because NetBeans can also generate the equals method. Okay, yeah, just do it by yourself, similar to the way we have done it here. So this is our item class. The question now is, can we add objects of this class to our singly linked list? The answer is definitely yes, because our linked list is generic. So I have another example here called test item SLL. Very similar to test integer SLL. The only difference is this time the linked list is going to be linked list of item, not linked list of integer. Okay. So we have SLL of item list equal to new SLL of item. We still have the scanner object, and we have option as an integer, but we don't have target like before. Rather, we have name and price. Okay. You will see what these variables are used for when we are doing, for example, adding to head or adding to tail. Okay. Okay, the menu is the same, no change. Okay, adding a new node at the head, another one at the tail, print all, delete from head, delete from tail, delete a given node, and then search. So no change in the menu. We're going to read the option from the user. Again, no difference in that. And then in the switch, we follow the 8 cases one by one. So here there is a slight difference. In the case of integer, we can call the add to head directly, as I showed you earlier. Okay, I changed it actually. So let's use the add to tail example. You can just say list.add to tail, and you say reader.nextInt. But in the case of item, we need two input actually to create an item object. So we cannot call the add to head directly. First, we have to read the two input from the user. So that's what we are doing here. Enter the item name. Okay, and we say reader.next, because if you are reading a string, you will use next, not next int or next double. So read the next, which will give you the name, and save it in this variable, string variable name. Okay. Next, read the price. So enter the item price. Price is of type double, so you have to use the read double, and you're gonna save the result in a variable price. So now that we have both name and price, we are ready to create our item object. Okay, and therefore to add that item to the list, we can do like this: list.add to head, new item, name, price. Okay, if you wish, you can create the item objects first before you add it to the list, but again, there is no need to do that. You can do it directly. Just say new here, new item, name, price. So an item object is going to be created and it will be added to the list. Okay, the add to tell is similar. We read the two inputs and then we say list.add to tell, new item, name, price. So the only difference is which method we are calling, add to head or add to tell. Okay, the print all will print all, only that now it is trying to be a bit more civilized by checking if the list is empty. It will give a nice message to the user that the list is empty. Otherwise, it will print the items. Okay. No change in delete from head and no change in delete from tail. But here, case 6 and 7, there is a big difference. You see, when you are deleting a given item, you don't have to ask the user, give me name and price, and then delete. No, we only need the name. Because if you recall, two items are equal if they have the same name. So you don't need the price before you can find the correct item to delete. You only need the name. Okay? Therefore, here, we will just ask the user, enter the name of the item to delete. And we're going to read the name. Okay? However, we cannot compare a name which is a string with item, which is a completely different object. But we know that we can create an item object with only name, because we have a constructor here that accepts only name. So what we do here, we call the delete method, but we will not send it a name, because name can never be equal to an item. Rather, we will say delete new item name. In other words, find an item whose name matches this one and delete it. Okay? We're going to receive the result of the delete. Remember the delete method? After deletion, it will return to us the item, the info of the node that has been deleted. Okay? In this case, the info is an item type. So you have to save your result to be of type item. So item result equal to list.delete new item name. Good. Now we have to check what is result, because if it is null, it means there was no item with this name. So we can print a correct message to the user. Okay, so here there is an if statement, therefore, if result is not null, we will say system.out.println result has been deleted. Okay, here you will see if that item that has been deleted is printed, you're going to see both the name and the price, because we are printing the one returned from the list, not our target. The target here has no price. Okay, you will see what I mean when we run the program. But in case result is null, we simply say sorry, name was not found. In other words, there is no item in the list with this name. Okay. Type. Now find is similar, exactly like the delete. We only need to read the name of the item to search. No need to read the price. It's very similar to the example I was giving you in the lecture. If you go to Mr. Shamrani's office, he doesn't ask you what is your ID, what is your major, what is your level, and so on. He only asks for the ID. So the same thing here, enter the name of the item. We read the item. And then we create an item object corresponding to this name. No need to pass any price. So we are calling the first constructor of the item class. Pass that item to find method. Is going to return to you a result. That result is of type item. So save it as type item. Okay. We could have used result like we did here. Doesn't matter. The question is, this item that we receive from the find, is it null or not? If it is not null, print it. Okay, and here when we print it, you'll see that it has both the name and the price. Okay, so here if it is not null, we print item was found. Otherwise, we say item was not found. All right. Okay, let's now run this program to see if it works as expected. So again, you don't run by clicking the run button here. You just right click and you say run file. Okay, so this is our menu, but actually it is not good. Something is missing. So I'm gonna stop it and make the correction. I will try to do the correction in the one you're gonna download. If not, please do the correction. The point is, you should never allow a program to stop without to stop waiting for you to enter an input without telling it what input you want. There should always be a statement saying enter something, so the user will know what to do. So I don't know how I missed that. We need to have the same line in the first example here. Before we read, there should always be a print statement telling what to expect. So we have here, enter, select an option 1 to 8. Okay, select an option, and then we read the option. So let's run it again. Run file. Okay, now looks better. Select an option 1 to 8. Okay, so we choose option 1. Say enter the name. Let's say the name is pencil, and enter the price. Price, let's say, is 2 riyal. Okay, so it has created an item object with name pencil and price 2.0, and it has added it to the list. How do we know? Print items. You see, this is what we receive: pencil, 2 riyal. Okay, let's add another one to the tail. So option 2, enter name. This time let's say pen, and price is 5 riyals. And then if you print, you will see that we have pencil 2, pen 5. Okay, one more item to add. Let's say add to tail again. Let's say eraser is the name, and the price is 3 riyals. Print the items, and you see we have 3 items now: pencil 2, pen 5, eraser 3. Okay, so this is the idea. Now let's try the find, so that you can see what I mean. If you want to say find whether there is a pen there, so option 7. You see here it is asking you just enter the name of the item. It didn't say enter name and price. So name is pen. And see what we have. It's a pen with price 5 was found. How was it able to match an object with only name as pen? If you remember, the price was 0.0, because if you call the first constructor, it will assign 0 to the price, as you can see here. How is it able to compare pen 0 and pen 5 to be equal? Because it is using the equals method, and the equal method, we say it should return true if the name only is the same. It doesn't care about the price. Okay, so the equals method is very important. This is how it is able to match. Okay, this is the idea. Let's go back. So we can do similarly with delete, the general delete. Okay, so for example, to delete an item, you don't need to give name and price. Option 6. So 6, delete a node by its name. So 6, enter the item you wish to delete. I want the name of the item, so we want to again delete pen. So you see, it's a pen with price 5 has been deleted. If you print the list, you will see that we only have pencil and eraser left. And the other methods are very similar. For example, delete from tail will delete the eraser. If you choose option 5, it will delete the eraser. So now only pencil is left. If we print all, we have only pencil in the list. Alright, so this is basically the example. And now, what task are we supposed to do? Okay, we have 3 tasks to do within the lab period. The first one says save the class test integer SLL as test double SLL and modify it to manage double values. Okay, so again, the idea is to show that our list is generic. It can work with integer values, with double values, with objects like item and so on. Okay, now here I'm going to show you something because we don't need to start from scratch in creating this test double. We already have test integer SLL. We can easily copy it and paste, refactor it if you like in the terminology of NetBeans, to create a new class. Okay, so that's what we're gonna do, and then make the changes. I will show you how to do this so that next time you just do it by yourself. And please take note, when I say refactor a class, I don't mean you should change the one I give you. The one I give you should remain as it is, as an example. What we want is to make a copy of it and then make changes on the copy, not the original program. So this is the test integer SLL. What you do is just right click and say copy. Okay, and then on the name of the package, do a paste. It will open a function, a menu for refactor. So refactor the copy. Okay, so this will allow you to change the name. So the name we want for our new class is test double SLL. Test double SLL. So you say refactor, and you can see that another main class has been added to you. So we now have three main classes: test double, test integer, and test item. So all I'm asking you to do in that task, let me try to zoom it a little bit. See, this class right now, even though it is named test double, it is still dealing with integer values. We want you to make the necessary changes to make it to manage double values. So obviously the first thing is to change the linked list here to be linked list of double, and then wherever you are adding an item, the item now should be of type integer. So you cannot use next int, you have to use next double, okay, and so on. So just go through the class and make sure you make the changes to make your class to manage double values, not integer values. This is the idea of the task. I should emphasize here, target is still, sorry, not target, sorry, option. Option is still integer, even though target is now double. You may have to break this declaration into two, into option, double target. Okay, because option is just one of these numbers, 1 to 8, is the numbers of the menu options. So option is still integer, but this now has to change to type double, okay? So that is basically the first task, to have another main class that will test double values. And you don't have to do that from the scratch. Just copy and paste the test integer SLL, refactor it as test double, and then modify it to manage double values. So this is very easy. I'm sure you can do it in a few minutes. Task number 2. Task number 2 is similar to test item SLL. We want our singly linked list to manage objects, but objects this time should be objects of type student. Therefore, your first task is to write a class student. Okay, similar to the item class. If you wish, you can refactor the item class, change the name to student, and then modify it as explained here. Now the student class has 3 variables, not 2. It has ID, which is of type integer. Please make it of type integer, not string. Name of type string, and GPA of type double. Okay, so the student class should have 3 variables: ID, name, and GPA. 2. The class should have 3 constructors. Again, not 2 like in the case of item. One constructor will take only ID. This is actually the one we're going to be using in case we want to call the find method or the general delete method. We only need to give the ID. So the key thing that will differentiate 2 students or make them equal is their ID number, not name, not GPA. If 2 students have the same ID, they are equal. So you're going to take care of that when we come to the equal method, which again I'm asking you to do. Okay, but this is basically why we need this first constructor, a constructor that takes only ID. Another one that takes both ID and name. So the student is a freshman student. He has not done any exam so far, so he has no GPA. Okay, but at least he has an ID and name, so you can have a constructor for those. And the last one, which is the main constructor, it is the one that will take all the 3 fields: ID, name, and GPA. And Shabab, I would like you to put this variable in the constructor according to this order: ID first, name second, and GPA last. In the past, students used to do this in many different random order, but since ID is the key field, it should usually be the first. So ID first, then name, then GPA. Okay, so this is the second part. The constructors should be 3, and they are as described here. Finally, your class should have equals and toString. Okay, so the same method as in item class. However, the equals should be comparing two students, as I said, based on ID, not based on name. You still need to typecast the object that you receive to be of type student. But when you are comparing now, you will compare the ID of the current student with the ID of the other student. Now here you have to be careful, because ID is primitive value. You shouldn't use the equals method. Rather, you should use equal because they are just primitive integer values. Okay, one integer value compared to another. Just use the equal method. Yani you don't have to use the equals method that I use here. We use equals here because we are comparing strings. Strings, they are not primitive type, they are objects. So to compare objects, you have to use equals. But in your case, what you are comparing is two integer values. Two integer values, compare them by just saying if id equal other.id. I hope that is clear. The last method to write is the toString, and as I emphasize, the toString must return only the field values separated by character. So example, I want to see only ID, tab, name, tab, GPA. There should be no other information in the toString. So it's better you do it by yourself. Don't allow NetBeans to generate the toString for you. Okay, so this is the first step of this task. Once you are able to create the student class, and I think this is very important, Shabab, I must emphasize, the student class is going to be used throughout the course. We're going to use it several times in many labs. So please, once you write it, make sure you keep it safe. In fact, keep all your programs safe, but particularly the student class, we're going to use it in many labs. So once you need to use a student class, you're just going to copy it from a previous lab to the new lab, like that. So this is going to be used many times, so please make sure you always have it. Okay, so once you have the student class, the next thing to do is to test your linked list, this time using the student class. So you're going to have another main class called test student SLL. So again, no need to create a new class. Just you need to copy test item and refactor it as test student SLL, and then update it to manage the student objects. So if I can just give you a hint, all you have to do here after you refactor the class, obviously this should not be SLL of item, it should be SLL of student, because you're going to store student objects there. Okay, these variables need to change. Instead of name and price, we're going to have ID, name, and GPA. ID of type int, name is still the same, of type string, but this should be changed to GPA, again of type double. Okay, the other change you have to do is here when you are adding the items. This time you have to read three things: enter ID, enter name, enter price. Once you have all the three inputs, you will create a new student object using those three inputs and add it to your list. Okay, you will do similarly here when you are adding to 10. You have to read the three input for student, create a student object, and add it to the end of your linked list. Okay, no change, I believe, in print all, delete from head, delete from tail, but these two other options you have to make some changes. because now it should not be enter the name of the item, rather enter the ID of the student. So here you should be reading an ID number, okay? And of course you're going to create a student with that ID to be able to delete or to be able to search. So this is basically what task 2 is about, testing your SLL class, still using the this time using the student class. Okay, so that is task 2. Now task 1 and 2 are basically about using the linked list. We now move to a higher level, implementing. We have already implemented many methods in the linked list, so this task is going to ask you to add more methods. This is the last task. So it says add the following methods to the singly linked list class. So you're going to open the singly linked list class. Okay, it's better you go to the end of it. Go to the end, but please here you have to be careful. Don't put your method inside the node class. The node class ends here, so your method should not be after this constructor. It should be here after the node class, because you are adding method to the outer class. Okay, if you don't want to do it here, you can do it here after find. If you think you're going to get confused, you can do it after find. Okay, so either you do it after find or completely after node class, because you're not going to add method to the node class. You are adding method to the outer class, which is the SLL. Okay, so add the following methods. What are the methods? 1, clear, to clear the list. I'm sure we all know how to clear a list by now. Just you need to set both head and tail to null, and the list will be cleared. Get first. We want a method that will return the information in the first node of the list. Okay, I'm sure you know how to do that. The first node in the list is accessed by the head. So basically head.info is what we want to return. But it will be a good idea to check that the list is not empty. If it is empty, you're going to return null. Okay, otherwise get the information in the head and return it. And also you're going to add get last. Okay, so very similar. To get the last info, you have to use the tail reference. Okay, so these 3 methods really are very, very easy. Just 1 line or at most 2 lines. Okay, you can do them. So the real methods are these 2. Okay, and those actually are the ones that will be graded. When you submit your work, the length and toString method are going to be graded. Each of them will have 1 point for a total of 2%. Okay, length. This method is expected to return to us the number of elements in the list, or how many nodes are in the list. So to give you a hint how you're going to do this, is very similar to print all, because you need to traverse the whole list from head until the end. Okay, so you're going to need a variable temp, which you will initialize to head, and you're going to keep repeating a loop until temp becomes null. But what are you going to be doing inside the loop? In the print all, we were printing the temp.info. But this time we want to count. We want to count the node. Each node you encounter, you need to count it. So what you do is, before the loop, initialize an integer variable. Maybe you can call it count or C or something like that. Initialize it to 0. Then in the loop, each time, as long as your temp is not null, you're going to increment that count by 1. Okay, so that at the end of the loop you return that count. Okay, this is the idea. So that count will give us the number of nodes in the list. You just need to traverse the list exactly as we did in print all, but instead of printing the values in the node, we're just going to count them. So you just be incrementing a counter variable. Okay, this is the length method. The last method is toString. We want our linked list to have a toString method. This toString method is expected to return all the info values in our list as one string. Okay, so for example, if your list has 3 nodes of integer consisting of, let's say, 2, 5, and 7, this is what we want your list to return. Maybe not separated by comma, separated by spaces enough. Okay, we want these values to be returned, as a string. This is what the toString will return. So again, if you notice, all what this involves is traversal, starting from head until the end, exactly like the length. The only difference is, instead of printing the values when you encounter them, you will append them to a string variable. Okay, so just like we had a count variable when you are doing the length, this time you need a string variable. You can initialize it initially as empty. Okay, so define a string variable, initialize to empty, and then you need a loop starting from head. Each time you will be appending temp.info to your string variable. So you see that when you reach head and you now append the temp.info to your empty string, it will become just 2. Okay, empty string plus 2 will be a string containing 2. Next time when you encounter 5, add it to the current string. Well, the current string contains 2. So if you add 5, okay, so actually you need to add a space and also the temp.info. So now you will have 2 and 5. Again, when you reach 7, you will append an empty string, a space and 7, like that. So this is what this method will do. Each time you reach a new node, you will append to your string a space and temp.info, so that by the end of the loop, your string will contain all the values, all the info values in the list, and this is what we should return. Okay, so this is the idea of the toString method. So those are the methods you should do. Now once you added this method, we need to test them to make sure they are okay. So the B part here is saying update your test student SLL class by adding options that test the additional method listed here. Okay, so just like we had method for add to test, add to head, add to tail, and so on, you should have a method to test length, to test toString, to test get last, to test get first, and also to test clear. Make sure you call this last one, as the last case, because once you call this, the whole list will be empty. Okay, yeah, so when you are running the program, call this option last to clear the list. Okay, this is the idea, and these are the tasks for this lab. As I said, I will be available throughout the lab period. If you have any issue, you can contact me through the Blackboard Ultra, and I'll try to help you. Thank you very much.